Hey everyone, let's solve the second question from today's weekly contest, that is number of subarrays with LCM equal to k. So we're given an integer array nums and an integer k, and we have to return the number of subarrays of nums where the least common multiple of the subarray's elements is k. A subarray is a contiguous non-empty sequence of elements within an array, and the least common multiple of an array is the smallest positive integers that is divisible by all the array elements. So basically in this question what we are given is we are given an array and we have to calculate the subarrays of this array whose LCM will be equal to this integer k which is given to us. So basically, so let's see. So first of all, what a subarray is. Subarray is basically a part of the array, a contiguous part of the array. So this we can call a single element as a subarray. This is a subarray, this is a subarray, this is a subarray, this is a subarray, right? All of these are subarrays. You can make combinations of them, right? Now we want to calculate the LCM of all these subarrays, and we have to see whether that LCM is equal to this k or not, right? So let's see. So for this given question, so if we see the subarrays who result in LCM 6 are, so this is a subarray, its LCM is clearly not 6. This subarray right here, its LCM will be 6, right? So we have one subarray whose LCM is 6. Then the next subarray, as I said, a single element can also be a subarray. So its LCM is also 6. Then we can, if we even take all these three, that is also a subarray and its LCM is also 6, right? And then if we take these two elements, 6 into, their LCM is also subarray. There's the subarray's LCM is also 6, right? And if we move further, like if we take 2, 7, or like if we form any other subarrays, right? And as you know, you have to form the subarray with, like, it should be continuous, right? So you cannot say that 3, 6, 2 and 1 is a subarray. That is not a subarray, right? So 3, 6, 2, 7, 1, it is a subarray. So but clearly its LCM will not be 6, right? So let's see how we'll code it, right? So basically what we'll use is, if you know that, let's say we have two numbers a and b. So if we calculate the product of a and b, it is always equal to the GCD of these two numbers and into LCM of these two numbers, right? So we already know how to calculate GCD, right? So if we simply like divide the product of these two numbers by GCD, we can get LCM of two numbers. Like, why are we doing this is because if we try to calculate LCM, we will have to go into, prime factorization and stuff, and that will be a bit lengthy. And for this question, as given in the constraints, nums I and also the nums length is under 1000, right? So we can use this approach and we can easily solve this question, right? So let's see how we can code it. Basically what I've done is, so here I have first written this LCM function which I just told you, right? So we calculated the GCD. This is an inbuilt function in C++ to calculate GCD, and it uses it calculates GCD in log of minimum of a and b time complexity, and then we have returned a into b by g, which is the LCM of these two numbers, right? Then in the above function I've looped through first inside the whole array, and then I have taken this LCM variable in which I am putting a -1. And now why am I putting a -1 here is because we cannot like if we want product of two numbers, right? So we need two numbers, right? If we want to calculate LCM, we need two numbers. So it is for the very first number, right? So I've taken LCM is equal to -1. So for the very first time that we come inside the second loop where we actually calculate for a subarray, right? If we come inside this loop, we check if LCM is equal to -1. If it is equal to -1, then we have to put nums j in it, right? So that we can get a product, and then we can, otherwise we'll keep getting one and we will not get an answer, right? So that's why I've taken LCM to be -1. And then inside this second loop, I'm looping through the subarrays, all the possible subarrays, and then I have just applied some conditions, right? So this is the condition where we have to, we are calculating if this is, if LCM is equal k, we are simply incrementing our count. And also we have applied this check, like if LCM becomes k, like it is of no use to calculate, like keep calculating LCM when it has, become greater than k. So it will remain greater than k for the rest of the other numbers, right? So that is why I have applied this break, so that we do not do unnecessary calculations. And so this is how we have to, and then we have returned count, and this is how we have to calculate the count of all these subarrays.